Hello, my name is Tyler Beamer and I am from Haywood Community College. This video is for Math 152, IN1, Statistical Methods 1. The purpose of this video is to show students how to create a scatter plot in Microsoft Excel and how to use some of the functions in Microsoft Excel to analyze a correlation that may possibly exist within the scatter plot. I have data preloaded into Microsoft Excel. The data are measured from children in 2 consecutive years, and the children were living close to a lead smelter. The first data category is the lead level. We have 1, 2, and 3 in this column. 1 indicates a low lead level, less than 40 micrograms. 2 indicates a medium lead level, greater than or equal to 40 micrograms in exactly one of the 2 years. 3 represents high lead level, greater than 40 micrograms in both years. We've had the age of the children, the sex. 1 is male, 2 is female. We have the year 1 blood lead level, the year 2 blood lead level. We have the IQ verbal score, the IQ proficient score, and the full IQ score for all of the children. What I want to do is create a scatter plot showing the correlation between the year 2 blood lead level and the IQF, which is the full IQ score. I hope to analyze the scatter plot to see if there is any type of correlation by visually inspecting the graph, and then also to find the correlation coefficient that is given by Microsoft Excel and the regression equation to further analyze the data. Okay, so I'm first going to highlight the column for year 2 blood lead level. Okay, scroll up to the top of the data, and then I'm going to press Control and I'm going to hold it while I highlight the IQF column. And this allows me to essentially highlight 2 columns that are not exactly right next to each other. Okay. Then I'm going to go to Insert. And notice that Excel allows me to create lots of different charts and graphs. I'm going to click on Insert Scatterplot. Click the drop down menu, and the first option creates a scatter plot of the data. Excel has assigned year 2, which is the first column that I highlighted, as my domain values, or the x coordinates, and the full IQ score, the second column that I highlighted, as the range values, or the y coordinates. This data is paired, so the ordered pair 18, 70 is a point on this scatter plot, and you can see it there. So I can essentially pair the year 2 blood level and the full IQ score for every child in the study, and every one of these points on the scatter plot represents a child with their corresponding year 2 blood lead level and their full IQ score. Okay. I want to label the chart scatter plot. Excel gives me the option to label the entire scatter plot. If I click on Chart Tools, Add Chart Element, Axis Titles, I can actually label the x-axis and the y-axis. Do this again for the horizontal axis. Okay. It's important to label those axes and the chart itself. If we don't have any of that labeled, when someone looks at it, it's just a bunch of random dots, and they're not really going to understand exactly what we're trying to show mathematically. Okay, so looking at the scatter plot, like I said, every one of these dots represents a child, and it has their year 2 blood lead level and their IQ score. Doesn't look like there's a lot of correlation. It looks like the data is centered in the middle at a horizontal line that's pretty flat. It does not appear that their IQ scores are changing very much based off of their blood lead levels. So that's the insight that I'm getting by visually inspecting the graph. We can also go one step further by looking at the correlation coefficient of the graph and also the regression equation. Once again, if I go to Chart Tools, add Chart Element, and go to Trend Line, I can start to find that equation that would describe the correlation and then also give me that regression correlation coefficient. Notice that we've got lots of options here. I'm going to choose linear. If we knew that our data behaved in a different manner, we may choose a different function to represent it. For our case and for our course, we'll stick to linear regressions. Okay, and notice that it has a line that pretty much is the line of best fit that goes through the middle of all those data points. And if I right click on that regression line, click on Format Trend Line, and go down to Display Equation and display R squared value, it gives me a little bit more information about that line and the correlation between the two data sets. So this equation is the equation that would represent this line. That's the line of best fit that goes through the middle of the data points. Essentially, that regression line we can use for predictions. If I thought there was a correlation between these two sets of data, I could use that equation or that line to make a prediction about a future blood lead level that I may have. So if a new child that we did not study previously existed, we might be able to make a prediction on what their IQ score was. However, if we look at our R squared value, our number is very, very close to 0. If our R squared value is close to 0, then that essentially tells us that there's really not a correlation between the two sets of data. If this number is close to 1, positive 1, then that would tell us that there really is a correlation between these two sets of data that we could then use our regression equation to try to make some predictions. But in this case, this number is really close to 0, so that's telling us that there's really not much of a correlation here. These child's IQ scores have not changed dramatically by their increased blood lead level. Okay, so hopefully this will give you some insight into how to make a scatter plot in Excel, also a regression equation, correlation coefficient as well. I hope you found this useful for this class, possibly other classes. Thank you.